All right, let's talk about something that looks like total chaos, but is actually hiding an incredible secret, a big cloud of data points. We're going to figure out how to take this mess of dots and turn it into a tool that can actually predict the future. Ready? Let's get into it.
So that's really the big question, right? You look at a scatter plot, and you can kind of see there's a trend in there, a story. But how do you actually grab that story and make it useful? How do you draw one single perfect line that captures what all those dots are trying to say? Well, that is our mission for today.
Here's the game plan. First, we'll cover the basics of what these trend lines even are. Then we're going to get our hands dirty and actually draw one. After that, we'll turn our drawing into a super useful math equation, use it to make some predictions, and you're going to want to stick around for the end because we're going to pull back the curtain on its secret connection to AI. Okay, so first things first, the problem of messy dots. Scatter plots are great. I mean, they let you see if there's a relationship at all, but that's all they do. They don't give you a tool for prediction. We need to go from this cloud of maybe, sorta, kinda data to a single, confident line that tells us where things are headed. And this is our tool, the line of best fit. You can also call it a trend line, and it's basically the hero of our story. Think of it like the ultimate average. Its whole job is to slice right through all that random, messy noise in the data and show you the real trend hidden underneath. It's our best guess, our model of the world. So how do we actually make one of these? Well, it starts out feeling a little like art, just using your eyes. But it really quickly turns into a science. This is where we take that fuzzy idea of an average line and actually put it down on paper. And there's a really simple way to do it. Just 4 steps. First, just picture a big ol' oval drawn around all the dots. Got it? Okay. Second, you're going to slice that oval right down the middle, the long way. Third, kind of wiggle your line around until it's balanced. You want about the same number of dots above the line as below it. And finally, and listen up, this part is absolutely crucial for what's next. Find 2 nice, clean points that your new line goes through perfectly. Okay, a line on a graph is great, but to really unlock its power, we have to translate it into the language of math. We need to give it an equation. This is how we give our line a voice, so it can start telling us things we don't already know. Hey, remember that 4th step, picking 2 points? This is where it pays off. We look at the line we just drew and find 2 spots that it slices through perfectly. So in this example, let's say our line goes right through 0, 1 and 5, 5. And notice something really important. These points might not be our original data dots, and that is totally fine. They just have to be on our line. All right, next up, we have to find the slope. The slope is just a fancy word for how steep the line is. Now, the formula might look a little intense, but don't worry. All it means is rise over run. You're just finding the change up and down and dividing it by the change left and right. That's it. So let's just plug our numbers in. The change in y is 5 minus 1, which gives us 4. The change in x is 5 minus 0, which is just 5. So our slope, which we call m, is 4 over 5. And if we do that little bit of division, we get our final slope, 0.8. Now just think about that for a second. That entire messy cloud of data, that whole trend, we've just boiled it down to a single number, 0.8. That tells us everything we need to know about how steep our line is. And now, for the final step, we put it all together. The classic equation for a line is y equals mx plus b. We already found our m, it's 0.8. And the b? That's just the y-intercept, or where our line hits the vertical y-axis. If we look at our first point, 0, 1, we can see it crosses at 1. So our final equation is y equals 0.8x plus 1. And boom, we did it. We have our equation. Now, a quick word of warning here, because this is a really common mistake. It is so tempting to just connect the very first dot to the very last dot. Don't do it. That ignores literally everything that's happening in the middle. Remember, the whole point is that your line has to represent the average of all the points, not just the 2 at the ends. Okay, so we've got this beautiful equation, y equals 0.8x plus 1. So what? I mean, what's the big deal? Well, the payoff is huge. We have just built ourselves a little prediction machine. We can now plug in any value for x we can think of, even one we've never seen before, and get a really good prediction for y. So let's try it. Let's put our new machine to the test. Using our equation, what do we think y will be when x is 10? Now, 10 might be way off our original chart, but our equation doesn't care. It can handle it. It's actually pretty simple. We just take our equation and swap out the x for a 10.
So y is going to be 0.8 times 10 plus 1. Do that quick bit of math, and we get 8 plus 1.
Which means y equals 9. And just like that, we did it. We used our model to look into the future, turning that messy cloud of dots into a specific, concrete, powerful prediction. And you know, there's a cool technical word for what we just did. It's called extrapolation. Anytime you use your trend line to make a guess about something that's outside the range of the data you started with, you're extrapolating. But what do these numbers in our equation actually mean? They tell a story. The slope, our 0.8, that's the rate of change. It tells us that for every single step we take to the right on the graph, we expect to go up by 0.8. And the y-intercept, our 1, that's just our starting point. It tells us that if x is 0, our prediction for y is 1. All right, you've been doing great. We've drawn a line, we've built an equation, we've even made a prediction. And you might be sitting there thinking, okay, cool, but this is just some stuff for my algebra class. Well, get ready, because this simple idea is one of the most important foundations of all of modern technology. The thing we just did, step by step, has a very famous name. It's called linear regression. That's it. It's one of the most fundamental techniques in data science and artificial intelligence. And this is not just a classroom exercise. I'm serious. This exact math is how simple AI models are built. It's the core idea behind trying to predict stock prices, or forecast the weather, or figure out what you're going to click on next online. It all comes back to finding that one perfect line through a cloud of dots. You know, the only real difference between what we just did by hand and what a huge machine learning model at Google does is just the scale. We used, a dozen dots? A computer uses millions, sometimes billions of them. But the goal is exactly the same. Take a mountain of messy information, find the single best line to explain it, and then use that line to make a prediction. So I'll just leave you with this thought. If a concept as simple as a straight line, something you probably learned about in middle school, is the engine behind some of the world's most powerful technologies, what other superpowers are just hiding in plain sight in the math we learn every day? Thanks for joining me.